Hello, everyone, and welcome to the second installment of our 2016 Spring Break Review Hints. As spring break comes to a close, I hope you all have had a good time. For those of you who traveled, that you had some great memories, and for those of you who were still in Michigan, that you at least got to relax some. So let's go on now to take a look at problem one from the second part of this exam. In this problem, what you're given is a graph that shows Karen's velocity. So you got to remember that is the velocity function. So make sure you identify that. If you notice, not on this graph because of how I cropped it, I missed the V of t on there. But at the top of the axis, if you look at your grid, let me see. Oh, there it is. Now you can see it. If we look at that grid, we can see the V of t right there. So want to make sure you identify that that is your velocity on this one. Now this one is an interesting problem because of the fact that it does kind of have a story along with it. Karen is riding her bike to school. She is on a straight road starting at time t equals 0 and time is in minutes, so you want to be aware of that as well. And arriving at school at time t equals 12 minutes. During the time interval from 0 to 12 minutes, her velocity in miles per minute is modeled by the piecewise linear graph above. Okay. Now, they want you to first find the acceleration of Karen's bicycle at time t equals 7.5 minutes. All right, in this case, for this part, for part A, you need to remember that the acceleration is the derivative of the derivative with respect to t of the velocity function. So what we're looking at in this case, you have to go and find that derivative, identify what the derivative is there. Now, one of the things that you have to be aware of on this one, please remember, be aware of the units. You'll notice that the t-axis, the horizontal axis, is in units of 1, but you'll notice the scale on the vertical axis, the velocity axis, is actually 0.1. So that's going to make a difference in terms of what each square technically represents, and therefore is can have a change in terms of what that acceleration is. So be aware of those units when you're doing that one. For part B, using correct units, explain the meaning of the integral from 0 to 12 of the absolute value of V of t dt. Now, again, what you have to remember in part B on this one, that when we look at the difference between the integral from a to b of V of t and then the integral from a to b of the absolute value of V of t. Okay. What you have right there, this particular integral, that first one, that is displacement. This is distance. So keep in mind, determine what use the graph to go through, and again, be aware of the units that you have on the y-axis, because that's going to make a difference on this one. Be aware of the units you have on the y-axis and then calculate. In this case, we are looking for this right here. Calculate the absolute value of V of t. Excuse me, the integral from 0 to 12 of the absolute value of V of t. And also be sure to go through always on these types of problems, you are going to have to be aware of units. Okay. Remember, one thing to remember when you're taking the derivative, the units are going to be the y units divided by the x units, and the units on a definite integral are going to be the y units times the x units. So keep that in mind as well. Then for part C, shortly after leaving home, Karen realizes she left her calculus homework at home. She returns to get it. At what time does she turn around to go back home? Give reason for your answer. Well, looking at that, I'm sure that you can probably kind of see what happened in her trip by if we use that storyline, that there is a travel. She traveled from for the she traveled for a certain amount of time, and then she had to go completely backwards and be actually end up back at zero. So I think you can kind of probably see where that occurs, and then there's a time that she's back at home. Getting her homework, and then she travels from that point forward, gets back on her bike, and is now riding to school. So look for that. Determine how you are going to make that determination about when she turns around. Think about what that means for the velocity when she turns around. Remember the difference between velocity and speed. And then part D, Larry also rides his bicycle along a straight road from home to school in 12 minutes. His velocity is modeled by the function W of t equals pi over 15 sine of pi over 12t, where W of t is in miles per minute. Time is going to be from 0 to 12 minutes. Who lives closer to school, Karen or Larry? Well, in this situation, you have to go through, there's a couple different things you're going to have to do. Number one, you have to take that integral of, you're going to have to go through, find, this is his velocity, so we integrate the velocity, that is going to be the displacement that takes place. The one thing you got to be aware of on that one, and just so that everything you are okay with it, remember to just make sure, guarantee yourself that that is always, that the function right there is always positive, so that we are always moving in that positive direction. In this case, I know it's positive because the sine function is always a positive number from 0 to pi. And I know that when I put 12, when I actually take 12 and put it in for t, I would get pi over 15 times the sine of pi, which actually ends up being 0. So I know that 0 to 12 is going to result in what's inside of here being an angle measure from 0 to pi radians. So in that, those ones are always positive. So I know that the integral of W of t is going to be the same as the distance, and therefore I can just go and calculate that aspect of it, find his distance from school. Now the other thing you have to be aware of, you have for the other part on this one, you have already, remember, you have already calculated in part B, you've calculated how Karen's total distance that she's traveled. Now, what you have to do is think of that in terms of the displacement. How you would use that to calculate the displacement, and then that will be her distance from school. So then you can make your determination from there. Now let's take a look at problem number 2. In this problem, they tell us that the rate at which people enter an auditorium for a rock concert is modeled by the function r, which we are told given right here, where t is from 0 to 2 hours. So really what's happening in this case is that they are opening the doors to the concert at time t equals 0, and then the concert starts 2 hours later, and that's when the doors will close. So we're only looking at this from 0 to, that's why we're only looking at this from 0 to 2 hours. R is measured in people per hour, so again, it is a rate, and keep that in mind on this one. No one is in the auditorium at t equals 0 when the doors open. So that's your initial value. Keep that one in mind. So we know because no one is in there when we start integrating, that's going to be a number of people. And when the doors open, the door closes, and the concert begins at time t equals 2. So they want to first find out how many people are in the auditorium when the concert begins. Well, remember when that concert begins, it's, this is the rate. So this is the rate people are coming in. Doors are open from 0 to 2. This is a calculator problem. So you can go ahead and just remember that's going to give you, when I take people per hour multiplied by hours, so it's indicating a definite integral, we get people. So in part A, In part A on this one, you want to go and just integrate from 0 to 2 on this one. And of that, of R of t. So go ahead and do that. For part B, find the time when the rate at which the people enter the auditorium is a maximum, justify your answer. Well, in this situation, you actually do have a couple of different options to go through. But remember, really, when you want to know when a function is the maximum, one of the ways to do it, this is a polynomial, so you don't have to worry about it being undefined. You should recognize that. So probably the easiest way would just be to take the derivative and solve and set that equal to 0 to identify when we're there, when we're at that point. Now remember, this is a closed interval too. This is a closed interval from 0 to 2. So remember, a function achieves its maximum and minimum inside a closed interval by the extreme value theorem. We know that's true. So you always need to check not only the critical points for max or min, but you also need to check the what's happening in terms of R of t for the for R of t in terms of at the endpoints and the critical points. That will also serve as your way to justify your answer. If you find the critical points, check all the critical points, check what happens at the endpoints of 0, in this case 0 and 2, and your justification will be complete with that problem. The total wait time in the next part. For all people in the auditorium is found by adding the time each person waits, starting with the time the person enters the auditorium and ending when the concert begins. The function w models the total wait time for all people who enter the auditorium before time t. The derivative of w is modeled by w prime here. And they want us to find w of 2 minus w of 1. The total wait time for those who enter the auditorium after time 1, t equals 1. So basically what we're looking at is what's the total wait time for the people that entered the auditorium after the doors had been open for an hour until the concert starts. Okay, now what you have to do again on this one, you want to find, one of the things you should recognize right away with this, that looks a lot like how we evaluate a definite integral. And what we're going to do for part C in this case, we're going to take the integral of w prime of t dt, and in this case we want it, looking at that, we know these, we can use this to identify our limits of integration. Obviously it would be from 1 to 2. So you have to go through and do that. Now you have a couple ways to do this one. Again, you can do this on your calculator. The nice thing about this particular problem, while it's not, there's some weird things happening, you can go through and multiply this thing out and do this by hand. It might take a little bit more time, but you do have your calculator too at this point. So probably the fast way to do it would be just plug that right in. It is math 9 is your definite integral. I would put this w prime of t in using that, and you can replace the r of t with what it's equal to. I wouldn't bother multiplying that out. I just put 2 minus t times r of t. Make sure you put parentheses around r of t as well when you put that in there. And you can go through and do that one. Now let's take a look at part D. This one, on average, how long does a person wait in the auditorium for the concert to begin? Well, really what we have to look at here, you want to know the average wait time per person. Okay, so per person. Now this is where you're going to need to go and use an answer from up above. You want to know how many people, because we want to know how long, what's the average time for all people at the concert, average wait time for all people at the concert. So now for part D, since we're looking at, again, the average wait time for all people at the concert, we have a couple things we got to be aware of. First thing you have to remember, we have to look at this in terms of how much time, what's the average for all the people at that concert. So we need to find the total amount of wait time for everybody there. And to do that, we have to go through to find that average wait time per person. That means we have to divide by the number of people. So for part D on this one, we're going to have to find the total wait time and we're going to divide that by total number of people. That will give us the average wait time per person. Now, the nice thing they did for you earlier, you did in part A, you did answer the question for how many people were in the auditorium when the concert began. So you already know, in this case, you already know what that is based on your answer for part A. And then the total wait time is really going to be similar to this in part C, except remember now we're going for everybody in the auditorium, not just for the people that entered in the last hour that the doors were open. So be aware of both of those. Go through and answer that question, see what you come up with. Now we get to question number 3. Question number 3 is the last calculator question. So, you know, as you're going through for this particular exam, questions 1, 2, and 3 were calculator, 4, 5, and 6 were non-calculator. So this is a different format than what you'll be seeing, but this one still is a calculator question. And as such, and if I remember, looking at this one earlier, I remember this particular problem, and quite honestly, I thought it was one of the more confusing ones as I was reading it. So if you found yourself being a little bit confused as to what's happening on that thing, it's okay. Note on this one, you have to be aware, because you're going to be dealing with profits on here, you have to be aware that they're selling the cable for $120 per meter. And for a fixed cable length, the cost of producing a portion of the cable varies with the distance from the beginning of the cable. So really what this gets down to is that you are going to be going through, and you've got to, in this case, realize one of the main concepts that we've tried to instill is the idea that the definite integral is an accumulator function. That as you increase the values, as you're going from a fixed value A, maybe it B, in this case 0, as B gets bigger, you're going to accumulate more value. And so what they're saying here is this is kind of like the rate that the cable increases, if you will, in dollars per meter. Okay? Now, what we have to do, we want to find Mighty Cable's profit from a sale of a 25 meter cable. Well, to find that profit, again, and they specify that here, profit is defined as the difference between the amount of money received by the company for selling the cable and the company's cost in producing the cable. So we have to find for part A here, we need to find the total revenue, and we're going to subtract from that the total cost. Okay, now again with this one, you do want to be aware what they told you up above. It sells for $120 per meter. We have a 25 meter cable, so that one, I think you can probably come up pretty quick what that is. Your calculator is there too, so you can do that fast if you want to use that, but it's not something that's going to be hard to calculate. What you now have to do is find the cost to produce that 25 meter cable, and we know that the cost is 6 times the square root of X dollars per meter. So to get the cost, I've got to take dollars per meter, multiply it by meter. So when we look at that, we're looking at a definite integral on that 6 times the square root of X. So you're going to want to use a definite integral for that one to find that cost. Using correct units, explain the meaning of the integral from 25 to 30 of 6 times the square root of x dx. Well, again, remember this, we've already kind of talked about it. That represents some sort of cost, so be aware of that and interpret that cost in the context of this problem. The next one, write an expression involving an integral that represents Mighty's profit on the sale of a cable that is k meters long. Well, to do part C, refer to part A, because you had to go through and find that profit there. So in part C, you need to go through and just use that, and instead of up here in part A, we use 25 meter cable. Now we've got a K meter. So kind of get the idea of what you have to do, but refer to what you did for part A to come up for part C's profit function. And then the next thing they want you to do is maximize that profit function. Well, if you know what the profit function is, you got a couple of different ways you can maximize that. Well, actually one way on this, because we don't have our calculator. I was thinking about the calculator. You got to go take the derivative. Take your derivative and see what that is. Oh wait, this is a calculator problem. So yes, you could use your calculator as well. You could graph that profit function, put in your calculator, see what you can come up with. But in this case, it's probably easier just to take the derivative and setting that derivative equal to 0, solving for x, and finding when that occurs, and then they do want you, one of the things that'll happen, this is one that you'll do a lot of good work. You do need to go and calculate what the maximum profit is, not just the cable length that will give the maximum profit. So what you're going to end up having to do is you got to take the derivative from C, find when that's going to be 0, and then plug that value into your answer for C and evaluate that particular definite integral there. And again, that can be done with a calculator. So that's where I would probably go with that one. At this point, this does end the calculator problem. So no, there's no calculator from this point forward. Now let's take a look at problem number 4. In this case, they've given us a region, and sometimes they will do exactly what you see on this one. Notice that they've given us the intersection point of the two curves. We know our two curves are y equals 2x and y equals x squared. The first thing I want you to do is find the area. Now, on this particular one, I think this one was about 3 points each for each one. So you got 3 points for finding the area, 3 points for part B, and 3 points for part C. So find the area. Okay, we've talked about that. Shouldn't be too difficult in terms of these things, and in terms of what you're working on. Now, what happens here in part B? You are told cross sections perpendicular to the x-axis. Remember, when we're perpendicular to x, we're integrating with respect to x. Functions we need to think of in terms of y equals. Okay, when we are perpendicular to the y-axis, we're going to integrate with respect to y. So in this case, though, notice that they don't tell you the shape. They don't tell you what the cross-sectional face is. So therefore, we don't have a formula that we're going to plug things into to get the area. They actually tell us. They're nice. They tell us that the area of the cross-sectional faces is this function. So I don't have to go and find that area formula, which is what I did when we were told that the areas were squares. We had to find that distance between the two functions and then square that to get that would be what we would integrate. In this case, they're just telling us this is what the area of the cross-sectional faces are, and if we want to find a volume, you integrate an area formula. So, and we're integrating with respect to x, so that one should be fairly easy to set up. Now, you do have to be careful because of how you're integrating sine of pi over 2x. So we'll see how you do with that. But otherwise, the setup on this is not bad. So you're basically going to get 1 point for your definite integral, the integrand 1 point for your limits, and then 1 point for that final answer. Next one, part C. Now this one here, another solid, has the same area as R. For this solid, the cross-section is perpendicular to the y-axis. So think of what it means because we're now perpendicular to the y-axis, what we're integrating with respect to. And what that means, in this case we're squares, so we were already talking about that. So what that means in terms of, for this problem, how we're going to go through and get our area formula. We know the area of a square is the length of the side squared. You've got to find an expression that will represent the length of that side. And we know because we're perpendicular to y-axis, that will tell you something about what we're integrating with respect to. So this one right here, you get 3 points. You get 3 points for 1 point for the limits of integration and 2 points for the integrand. Okay, that it's all correct in there. Everything that needs to be there is there. You don't have to evaluate this one. Okay, so please, you got to be aware of that as you look at a problem. If they tell you do not evaluate, right, but do not evaluate, make sure you do something to highlight that. Make sure you realize you don't forget and spend time evaluating something that you don't need to. Now let's go on the next problem. In this case, we're looking at problem 5 now. And they've given us a table up above. The table is x and f of x. So our independent variables, the independent variable is x, so those values are up there. The function values are here. And it's a twice differentiable function for all real numbers. The table above gives value for f at selected points on the closed interval from 2 to 13. Part A, estimate f prime of 4, show your work that leads to your answer. You've done that a number of times. This one, you've seen that at least on the free response we did in class. You saw this same problem basically on the free response you've worked on during the first part of this, and now you see it here, so it shouldn't be too difficult with that. The next one is you have to evaluate this definite integral here. All right, well, what you're going to want to do, you want to integrate that. You just want to go through and do the integral. So you've got to go through, you've got 2 things here. You got 3, you have to integrate 3, and you have to integrate negative 5 f prime of x dx. And then just use the fundamental theorem of calculus to answer your question. Remember, it's not, the 2 and the 13, those happen to be values up here, so that can help you in terms of identifying how things are going to work out in terms of that definite integral. The next part, use a left Riemann sum with the subintervals indicated by the data in the table to approximate this particular function value, or that particular definite integral from 2 to 13. Okay, so you want to use a left-hand Riemann sum. Remember, that is a rectangle you're looking at base times height. So you're going to use, because it's a left-hand endpoint, left-hand Riemann sum, you want to use the left endpoint to calculate what the height of the rectangle is. And the base of the rectangle is just going to be the change in x. And so you've got to look. Now in this case, this is, if you'll notice on here, the x values go from 2 to 3 to 5 to 8 to 13. That is not a regular partition. So you've got, each rectangle is going to have a different height that it's going to use, okay, or different base that it's going to use. So be aware of that, and you're just going to have to write that out. In terms of that, and then do the calculations from there. It's not very difficult calculations, and then go and add those up. For part D, Suppose f prime of 5 equals 3, f double prime of x is less than 0. Now that's a key part on this one. The fact that the function is concave down tells us something. When a function is concave down, that means graphically, if I go through and draw that function, if it's concave down, when I have a tangent line at a particular point, that tangent line will always be above the curve, where if it was concave up, the tangent line would have to be below the curve. And a secant line which connects 2 points on the curve, the secant line is always going to be under, the portion that we're looking at where between the 2 points where the secant line intersects the curve. When it's concave down, that secant line will always be underneath, will be below that. So what happens on this one here? For part D here, you wanted to go through. We know that since it's concave down, I know the tangent line is going to be above the curve at 5. So they tell me what the derivative at 5 is. We know what the point is. We know from pre-calc, the point slope form, y minus y1 equals m times x minus x1. We can now plug our slope and our point in for there, and I know my tangent line is going to be y plus 2 equals 3 times x minus 5. There's the tangent line, okay? Plugging it in there. Now, you go through, they want you to go through and approximate, use the tangent line to approximate f of 7 and show that it is definitely going to be less than 4. That f of 7 is going to be less than or equal to 4. With the secant line, you're going to have to go, you want to find the secant line, in this case from 5 that connects the points at 5 and 8. You want to find that and then use that secant line to approximate f of 7 and show that that must be greater than or equal to 4/3. The key on this is recognizing that because we are concave down, that tangent line is above the curve and the secant line will be below the curve. And that will help you out in terms of what's happening with this part D on this problem. Now we get to the last problem. In this case, they tell us we have the graph. They indicate that the graph is the derivative. So we want to make sure we highlight that, recognize that, that is f prime. And f prime is told to us is given to us by this piecewise function right here. It's g of x when we're from -4 to 0. And it's 5x to the negative x over 3 minus 3 when we're going from 0 to 4. Now, we know the graph of a continuous function f prime is shown above, has x-intercepts at x equals 0 and x equals 3 ln of 5/3. So they're telling us the two locations where f prime is equal to 0. And we know that the graph of g is a semicircle. And we're also told that f of 0 is equal to 5. Okay, so the first part on this one, for all values from -4 to 4, find all values of x for which the graph of f has an inflection point. Justify your answer. Remember, inflection points are going to occur when the second derivative of f, which we're told f prime, so we have to identify what that second derivative is going to be, when that second derivative is 0 or undefined. So we can go through and deal with that, and then determine based on there, do we have a change in concavity or not? So that's the first part there. So you have to just determine when this function, based on the information you're given, when f is going to go from concave up to concave down, or concave down to concave up. Then The next part, find f of -4 and f of 4. The one thing that's a little bit different with this one, a lot of times people get used to in the calculator section that things don't get too super crazy, or in the non-calculator section that the numbers seem okay. In this case, you have a semicircle over here. And we need to find, now the one thing you have to be aware of on there to find with f of for f of -4, you got to look at that. We're looking for the area that's between the semicircle and the x-axis. So we're looking for that. Well, if you notice here, if I draw that across, you might see a rectangle, and we're taking out the area of that semicircle. Please remember, the area of a semicircle is going to be 1/2 pi r squared. Okay? A lot of people can forget the 1/2 on that. They start, oh, it's pi, they work with they recognize that you're dealing with a half of the area of the circle, but a lot of times people will forget to take that 1/2, so be aware of that. Also remember, in this case, we're starting at 0. So one of the things you're going to have to remember on this thing, you got to think of f of x is going to equal 5 plus the integral from 0 to x of basically f prime of t dt. Okay, so I can plug different values in for x to go and calculate that. So when I want f of -4, I've got to remember that f of 0 is equal to 5 to make that calculation. Remember the integral here, if I don't deal with that, that's integral right there is just going to calculate the displacement from the starting point, not what the actual value is. And then f of 4, same thing, only this one you are going to have to integrate it. It is something that you can integrate. 5e to the -x over 3 minus 3 is something that you do know how to integrate. If it's more helpful, make sure to do a u substitution, but I will leave that up to you in terms of what you have to do in terms of calculating that. And then for part C on this one, from -4 to 4, find the values at which f has an absolute maximum. Justify your answer. Okay, so you're looking at that graph. Think about what must be true when a function is going to have an absolute maximum at a particular location. Okay, in terms of, and think of it, because your graph, it has to have something to do with f prime. So think about if a function has an absolute maximum, think about what's going on with its derivative at that point. Okay, and with that, make sure you use that portion to justify your answer. And with that, this does now end my hint video. I hope it was somewhat helpful as you've progressed through. And we will now see you next time. Next time you hear my voice will be when we're in class on Wednesday the 13th. Remember, on Monday will be B-Day. So you can, if you want to come down during SRT and ask any questions on this, you can do that. Otherwise, Tuesday is the SAT day for the juniors, and I think we have testing for other underclassmen. And then Wednesday and Thursday will be more testing, and those will both be A days, if I remember right. So with that, I hope you are enjoying your break and that you have gotten your rest, and I will see you, if not Monday, on Wednesday. Take care.